Hi guys, and welcome again to another episode of the Seaman Vlogger. If I remember, from my previous vlog, I show you or I teach you how to calculate the compass error by using of the Norris nautical table. Hi guys, and welcome. Today, I'm going to show you on how to compute a compass error using a Norris nautical table. And now, I'll show you how to compute a compass error by using a scientific calculator from the ABC table. And let's begin. But if you close your eyes, okay, so let's start the tutorial on how to compute compass error on using scientific calculator in the Norris ABC table. Okay, by the way, if you like to know, for example, where do I get the GPS, where do I get the bearing, where do I get the variation and deviation, just kindly watch my previous video or my previous vlog, which the how to use the how to compute the compass error. Everything is there. Okay, so our given is 22 July 2018, and the GMT is 080800. Latitude 3855.7 south. Longitude 14245.7 east, with a course of 288, and magnetic compass is 278. Now, I will have the moon for the subject. Then, declination, example, you have south 1508.6. GHA, which is you will find in the in the nautical almanac, but just try to watch my other vlog, which is the how to compute compass error. Everything is there. So for example, you have a GHA of 182 16.7. Increments and correction, you have 1 degree 54.5. So to get the GHA, always plus 182 and you will have the value of 184 degrees 11 minutes. So you have the 12, so you're going to convert that into minutes. 12 divided by 60, 2. Then to get the LHA, you need to longitude 142 degrees 45.7 east. So your LHA, if longitude east plus longitude west minus, so we have the east, so it will be plus. You have the value of 3 to 6 degrees 56. So the 54 seconds, you will convert that into minutes. So 54 divided by 60, so it will be 9. Excuse me. So this is the part we're going to use the calculator. We will not use the Norris nautical table. So A, B, C. Okay, for the formula of A, so formula for A, tangent latitude divided by tangent LHA. For B, tangent declination sine LHA. For table C, actually there's no formula for C because that's the value of A and B. I'll just make a note. So same name, add, different name, subtract. Okay, for the Z, we need the value of Z. So C, which is this one, times cosine lat equals the value or the result. Then the 1 divided by value inverse tangent is equals to Z. Okay, so we already have all the formulas. We're going to start to compute for A. So A. So as the formula says, tangent, latitude, okay? Take note, if you have latitude south, you will add the negative. If you have north, just remain it positive. So tangent latitude, 38 degrees, 55.7 minutes, divided by tangent LHA, which is this one, 326, 56.9 equals 1.24. So as per ruling of the A, so label opposite to latitude except LHA between 90 to 270. So we have LHA 326 degrees, or let's just say 327 degrees. So you will have the value or the sign of north. The next B, tangent, declination. So you have declination south, put a negative, 15 degrees, 8.6 minutes, divide, sine, LHA again, 326, 56.9. So you have 0.49. So for the sine, the ruling here is take the sign of declination. So you have the declination sign of south. So you will have south. So we will compute for the value of C. Take note, if same name, add. If different name, minus. Then take the higher side, the higher digit, which is the north. So we will bring down the north. Then 1.24 minus 0.49. It will be 0.75. Then this north, you can bring down here. Then we will now compute for the Z. So as per my formula, so C, the value of Z is 0.75 times cosine latitude, which is you have south, so negative 38 degrees, 55.7 minutes, then equals, so you have 0.58. So the value is 0.58. Then 1 divided by 0.58 equals inverse or shift to tangent, then equals, you have 59.8. Then what's the sign here? Take note, if east, LHA 180 to 360, west 0 to 180. So we have east. Okay. Now, for example, you have a true bearing. The Z is the true bearing. So it 59.8. So for example, you have a gyro bearing for the moon is 60 equals gyro error 0.2 west. If the gyro bearing is greater, it will be west. If the gyro bearing is less or the true bearing is greater, it will be east. Then gyro course, it's 288. True course. Remember, if you have a west sign equals, you will subtract, and if you have east, you're going to plus. So 287.8. Variation. For example, you have a variation of 11.2 is ME, 276.6. Then magnetic compass, 278. Then deviation. So deviation is 1.4 west. True course, magnetic compass is equals to compass error. So your true course is 287.8, magnetic is 278. This one, for the value of, or the sign of declination, if this is greater, it will be west. If this is greater, it will come east. So the greater here from both ME and MC is the 278, so it's west. For this one, if this magnetic compass is greater, west. If true course is greater, east. Always minus. So the value of compass error is 9.8 east, because true course is higher than magnetic compass. Then true bearing. True bearing is 59.8. Compass bearing equals 50. So if you have east here, it's minus. If you have west, it's plus. Okay? So for correcting, T, V, M, D, C. True course, 287.8. Variation is 11.2. So equals 276.6. Your deviation is 1.4. 278. So you have magnetic compass of 278 and 278. So it means your computation is correct. By the way, from the correcting of TVMDC, if you have east, it's minus. If you have west, it's plus. So there it is. We've completed to compute the compass error by using of the scientific calculator for the Norris table ABC. I hope you like it and you gain some knowledge for it. And please like, comment, and subscribe to my channel. It really helped me a lot when I have a subscriber. Thank you, and see you next time for my next vlog.
Like and subscribe the Seaman Vlogger.
Okay, thank you.